Combustion air. Why flames need room to breathe. Episode 4 of the Gas Service animated series. A gas flame is hungrier than it looks. Every cubic foot of gas it burns consumes several times its own volume in air. Theoretical air for the chemistry, excess air on top of that, and dilution air for the vent. Starve the flame and combustion turns incomplete. The crisp blue cone goes lazy and yellow, and the burner starts making carbon monoxide, a poison you cannot see or smell. That is why the code treats the air supply as seriously as the gas supply. So where does the air come from? In an older, leakier house, it seeps in around windows, doors, and framing, often enough to feed the appliances on its own. The code's standard method draws the line at 50 cubic feet of room volume for every 1,000 BTU per hour of appliance input. Take a furnace and water heater totaling 135,000 BTU per hour. They need 6,750 cubic feet. A large open basement qualifies, but a small utility closet comes nowhere close. That space is confined, and it must be given air another way. And in a tightly sealed modern house, even a big room can fall short, so the code has a stricter method based on measured air changes. Fix number 1. Borrow air from the rest of the building. 2 permanent openings connect the confined space to a larger indoor space, one starting within 12 inches of the ceiling, the other within 12 inches of the floor. Each opening needs at least 1 square inch of free area for every 1,000 BTU per hour of total input, and never less than 100 square inches. For our 135,000 BTU per hour example, that is 135 square inches each. The high and low pair lets a gentle loop form, cool air and low warm air returning high, so the appliances always breathe. Fix number 2. Bring the air straight from outdoors. 2 openings again, high and low, but the sizing changes with the path. Openings direct to the outside or connected through vertical ducts need 1 square inch for every 4,000 BTU per hour. Horizontal ducts move air less easily, so they need twice the area. 1 square inch per 2,000. Our 135,000 BTU per hour room needs about 34 square inches per opening going direct, or about 68 through horizontal ducts. There is also a single high opening option, sized 1 square inch per 3,000, with clearance rules around the appliance. Here is the trap. A hole is only as good as its free area. Cover an opening with a louver or grill, and the blades block part of the airflow. When the maker does not state the free area, the code says assume metal louvers pass 75% and wood louvers only 25. So a 100 square inch wood louver delivers just 25 square inches of air. Screens can be no finer than 1/4 inch mesh. Louvers without a motor must be fixed open, and motorized louvers must be interlocked and proven open before the burner lights. Even perfectly sized openings can be beaten by the competition. A clothes dryer, kitchen and bath exhaust fans, and a roaring fireplace all throw air out of the house and pull it into negative pressure. Get enough of them running, and a natural draft appliance can lose the fight. Flue gases spill backward into the room instead of rising up the vent. That is why the code requires makeup air where exhaust equipment interferes, and it allows engineered designs and mechanical combustion air systems that duct outdoor air in at a set rate, interlocked so the burner cannot run without its air. So on a service call, air gets verified, never assumed. Measure the space and total every appliance's input to check the 50-to-1 rule. Confirm the openings exist and are sized right, high, and low, with screens intact. Look for the classic mistakes: openings stuffed with insulation, painted shut, or sealed over during a remodel. And after anything changes the air, new windows, new exhaust fans, a finished basement, test the appliances for spillage under worst-case conditions. When combustion air is in doubt, follow the code, the manufacturer, and your company's procedures. This is carbon monoxide territory, and it is never a guess. The rules of breathing room: 50 cubic feet per 1,000 BTU per hour decides confined or unconfined. Indoors, 2 openings high and low, 1 square inch per 1,000. Outdoor air works harder, so its openings are smaller. And watch the thieves. Louvers cut the free area while exhaust fans steal the air itself. Next episode, pipe sizing, getting full gas flow to every appliance.